All right, lesson 6, solving rational equations, part 1. So equations that contain rational expressions are called rational equations. So if you see an equal sign, you know it's an equation, not an expression, and you can actually solve for what the x is. Now this can get a little bit confusing because before we solved for x, but it was our non-permissible values. So the non-permissible values are things that make the equation don't work. The solutions, what we're going to be finding today, is what, if you put in for x, the left side will equal the right side. Okay, so left side equaling right side. So we need to figure out what can we put in for the values. And there's these 6 steps. Okay, so list your non-permissible values first. So for this first example, x cannot equal 0. Because if you put 0 in for x there, those denominators become 0 and the whole thing doesn't work. The lowest common denominator. So between x and 4, the LCD is 4x. And you're going to multiply each side by 4x. So in this example, we can actually simplify. These are the same denominator, so we can actually add those two fractions. So we have 3 over x is equal to 3 over 4. Now you might be going, all right, Mr. Blackwell, I can just see this, and the numerators are equivalent, so x must equal 4. Well, that's great, but I want to show you the steps so you can kind of follow the process more than just looking at it and understanding it. Okay, so the lowest common denominator is 4x. So we're going to multiply each side by 4x, like that. So you're going to end up with 12x over x is equal to 12x over 4. Okay, and if we simplify a little bit here, you end up with 12 equals 3x, and then if you divide by 3, x is equal to 4, which we knew already, but you can kind of see the process. So let's take a look at the one on the right here. Okay, first of all, let's talk about our non-permissible values. X cannot equal 1 or 0. And our lowest common denominator between x and x minus 1 is, in fact, those two things multiplied. So we're going to multiply the right side by the entire LCD, and we're going to multiply this side by the entire LCD. And what happens here is you actually end up getting rid of your denominators, which is going to be handy. So on the left side, we're left with 2x, and the right side, we're left with 3 and x minus 1. So no denominators, and we can actually go ahead and solve this. So 2x is equal to 3x minus 3, and if you rearrange this, so add 3 to each side, you get 2x plus 3 is equal to 3x, subtract 2x, subtract 2x, and x ends up being 3. Okay, now this is a solution. It's different from a non-permissible value. The solution means that if we put in 3 into the equation, the left side will equal the right side. Okay, here we've got another example. So let's start off with our non-permissible values. So x cannot equal negative 3. That's it. And the LCD is, in fact, 3 plus x. Okay, this is a denominator of 1, that's a denominator of 1. So you're going to multiply all 3 things by that LCD. So 3 gets multiplied by 3 plus x. The 2 over 3 plus x gets multiplied by 3 plus x. And 5 gets multiplied by 3 plus x. So all 3 things get multiplied by that LCD. The only one that's going to simplify here is going to be that term there. So let's expand this. So 9 plus 3x, what sign is there? Positive. Plus 2 is equal to 15 plus 5x. And let's go ahead and solve. So we have 11 plus 3x is equal to 15 plus 5x. Subtract 3x and subtract 15. So 2x is equal to negative 4 divided by 2. So x is equal to negative 2. That's our solution. And we've written down our non-permissible values. So we are good to go. All right, one more example here. Okay, so first of all, non-permissible values. X cannot equal 0 or negative 1. Perfect. So the LCD of all three terms is going to be 2x and x plus 1. Why not the other x? Well, this x and that x are similar, so we actually don't need to multiply by another additional x. Okay, it'll all work out. Trust me. Okay, so the LCD is 2x and x minus 1. So let's go ahead and multiply all this stuff here. Okay, so you end up with 2 multiplied by 2x and x plus 1 over top of x, plus 3 multiplied by 2x and x plus 1 over 2x is equal to 4 multiplied by 2x and x plus 1 over x plus 1. So let's go ahead and simplify some stuff. So 2x and 2x, and the x plus 1, the x plus 1. And over here, the x and the x actually simplify. So the left side, you're going to be left with 4x plus 1, and also 3 multiplied by x plus 1 over, the 2x got simplified. That's why we're doing it. And that is equal to 8x. So we have to continue our algebra here. So 4x plus 4 plus 3x plus 3 is equal to 8x. So you've got 7x plus 7 is equal to 8x. And if you subtract 7x, you've got x equaling 7, which is our solution. And we've also got our non-permissible values, so we are good to go. Okay, here's another example. It's a little bit more complicated. The LCD is both of those things. So you're going to multiply the left side by that. And the right side by that. And see what cancels out. So 2x plus 3 and the 2x plus 3, and the 3x plus 5 and the 3x plus 5, those will simplify. So you can cross those out. Okay, and you're going to be left with 3x plus 5 and 4x minus 2 is equal to 6x minus 1 and 2x plus 3. So if you FOIL this, you're going to get 12x squared plus 14x minus 10 is equal to 12x squared plus 16x minus 3. And now you got to do a little bit of algebra. So you're eventually going to make your way. If we subtract 12x squared from either side, it's nice that those will simplify. And if you subtract 14x, you're going to be left with negative 10 equaling 2x minus 3. And if you add 3 to each side, you're now at 2x equaling negative 7. So x is equal to negative 7 over 2. That's your solution. We've also written our non-permissible values, have we? Nope. So x cannot equal negative 3 over 2 and negative 5/3. And those would come from that stage there. Okay, we've got 2 more examples. So first of all, the LCD is actually x minus 3. okay? And our non-permissible values, x cannot equal 3. So let's start with doing that. So x cannot equal 3. This is very important. Okay, I'm just going to do a little star there for a second. So let's multiply everything by x minus 3. Okay, and you'll notice that it actually simplifies there and simplifies there. So you're going to be left with 8x plus 10 minus 4 times x minus 3 is equal to 10x plus 4. Okay, doing all right so far. So at 8x plus 10 minus 4x plus 12 is equal to 10x plus 4. Okay, let's do some collecting of like terms. So 8x minus 4x leaves me with 4x. And the positive 10 and positive 12 is 22. That equals 10x plus 4. Okay, and let's go ahead and solve. So you're going to get 6x is equal to 18. So x is equal to 3. So that's our solution. Well, hold up. Check this out. Our solution is x equals 3, but our non-permissible values say we can't have 3. So in this case, there is no solution. And that's because of our non-permissible values. All right, last one. Okay, let's go ahead and figure out what we got to do here. So our lowest common denominator is 6 and 2x plus 5. And what about the 2? Well, you don't have to include the 2. You could, but once we multiply by 6 and 2x plus 5, the 2 is actually going to simplify. Okay. So the left side, it's going to get a little busy, shall we say. So let's multiply 6 and 2x plus 5 multiplied by 2x minus 1 over top of 2. And then we're going to subtract 6 and 2x plus 5 multiplied by x plus 2 over top of 2x plus 5. And that's going to equal 6 and 2x plus 5 multiplied by 6x minus 5 over 6. And let's do some slashing here. Okay, so the 6 and the 2 will simplify, and now it would be 3 there. And the 2x minus 5, or 2x plus 5 and 2x plus 5 will cancel. And then our 6 and our 6 cancel out. So let's rewrite with the stuff that we still have. So 3 and 2x plus 5 and 2x minus 1 minus 6 and x plus 2 equaling 2x plus 5, 6x minus 5. Okay, one thing I haven't written down is our non-permissible values. So x cannot equal, so 2x plus 5 so negative 5 over 2 is what we cannot have as our non-permissible value. All right, so back to the question. Let's do some expansion and figure out what we got. So if you eventually expand all this, you will get, well, why don't we just do it? So we're going to expand everything. So 2x, that gives me 4x squared minus 2x plus 10x minus 5. And then we get minus 6x minus 12. And that equals 12x squared minus 10x plus 30x minus 25. And collect some like terms here. So plus 20x minus 25. Okay, we've got to do another expansion. 12x squared plus 24x minus 15 minus 6x minus 12 is equal to 12x squared and that part remains unchanged. So we got to collect some like terms now. So 24x and negative 6x will give us 18x, and then the negative 15 and negative 12 will be negative 27. Okay, so let's do some solving here. I'm just going to move this x equaling cannot equal negative 5 over 2. All right, so subtract 12x squared. See you later. Okay, and if we subtract negative 18x, we're left with negative 27 is equal to 2x minus 25. And if we add 25, we'll get 2x is equal to negative 2. So x equals negative, whoa, and I wrote that really poorly, negative 1. Okay. And so that's our solution. And you wouldn't write it in this form. You would rewrite it x equaling negative 1. Okay. So don't leave it like that. Put it in terms of x. Okay, so our x cannot equal negative 5 over 2, and our solution is x equals negative 1.